So now we can start with the one more topic here, the law of reflection. The law of reflection in vector form. Right, this is the topic name. And the reflection, although we have discussed the reflection, the laws of reflection, that the angle of incident and angle of reflection are same. The another law is that the incident ray, reflected ray and normal to the incident plane is in the same plane, right? But we have to write the reflected ray vector, right, like this. Suppose this is the incident plane and this is the normal unit vector, right, in the direction of the normal of the reflecting surface. This is the incident vector, right? This is the E1 vector, right? It is the incident ray, all right. And this is the reflected ray, all right. And in this direction, the vector is, suppose the unit vector in this direction is supposed to be E2, right? So we have to find what is the E1. E1 is the unit vector, you should write here, E1 is the unit vector along the direction of, incident ray. The E2 vector, unit vector along direction of reflecting ray, right? And N is the unit vector along the direction of normal to the incident plane. Is it clear or not, you tell? If this angle of the incident is I, this angle must be equal to I. All right. So we have to find this E2 vectors. Getting or not, you tell? So if this is the E1 vector, this is the E1 vector, you can write, extend this vector in this way. Suppose this is the E1 vector like this, right? And if you join this, right, this is the point of incident here, and this is the normal direction. So at this point, this is the E1 vector, fine, this is the E2 vector, and you join this line. So we have to find this E2 vector only. Is it clear or not, you tell? Right. So one more thing, right, if you consider this is the line A, this is the line A into B. Is it clear or not? Right. So if you assume this is the O, fine. So OA vector in this triangle OAB, right? OAB in triangle OAB. What will you write? According to the vector rule, right? Suppose this vector is assumed to be the AB vector like this. OA plus AB is equal to what? OB. OA vector plus AB vector is equal to what? Say OB vector, right? What is the OA vector? It is the E1 vector plus AB vector is equal to E2 vector. So we have to find this E2 vector only, right? This is the unit vector. This is the unit vector along the reflected ray. So E2 vector is equal to E1 vector plus AB vector. The basic thing is that we have to find this AB vector. Are you getting? Listen one thing. If any vector you want to write, suppose this is the vector A is nothing but equal to the magnitude of the vector A into the unit vector in this direction, right? This is the formula of the this is the way to writing the vector. So in the same way, if you want to write this AB vector here, all right, so the magnitude of the AB vector, if you are fine, and what is the direction in this direction, what is the unit vector? The N vector is the unit vector. Is it clear or not? So basically this distance AB is the distance multiplied by unit vector, right? So here the AB vector may be written as, right, the AB and unit vector in the direction of the AB, and normal vector are in the same direction, right? So you have to write this AB vector like, so you have to find this AB magnitude. Is it clear or not, you tell? Right, right, copy this first. Copy this. So you have to find this distance AB. So how would you find? Listen one thing. This E1 is the unit vector. Unit vector, and this E2 vector is what? You may write this the E2 vector. Right. This E1 vector and E2 vector are the unit vector. Therefore, their magnitudes are 1. Right. So if this is I, this is what? It is also I. If this you assume to be this distance x, right? So cos I, what is the cos I? Cos I is nothing but base upon hypotenuse. This magnitude is 1. This distance, what you are assuming, this distance is to be 1. So cos I is equal to base upon hypotenuse. So x is equal to cos I. So what is the AB value? The A, if this is x, this is also x. Is it clear or not? So if it is x, it is also x. Fine. Like this, it is also x. So the AB is nothing but 2x is equal to 2 cos I. Right. So I'm writing this side. So E1 is equal to 2 cos I n cap. Right. This is the one thing. Another thing, how to find the cos I? We know this is known, and this you have to find, the E2 vector you have to find, and the incident angle is I suppose, and the normal vector you know, right? So what can you write? Listen here, if you consider this is the E1 vector and this is the n vector, right? This is the n and this angle is, right, I. So what is the angle between the E1 vector and the n vector? This is n cap, this is the E1 cap. So what is the angle between them? Say 180 minus I. Is it clear or not? If this is the E1 vector, fine, this angle is I cap, 180 minus I. So how would you find the E1 cap and n cap? I am writing this side, E1 dot n1 cap. You know the A dot B vector. A dot B is nothing but AB cos theta. So E1, I am writing this side, E1 dot n cap, mod of E1, mod of n cap, and the cos of angle between them. So if this is the E1 unit vector, this is the n cap unit vector, what is the angle between them? Say cos 180 minus I. Is it clear? So it is 1. It is unit vector, therefore its magnitude is 1, 1 and minus cos I. Right, it is minus cos I. You understand or not? So cos E1 dot n cap is equal to minus cos I. So what is the cos I? Say cos I value is this. Is it clear or not? So therefore the E2 vector, this is the unit vector, this is the unit vector in the direction of the reflecting ray, is equal to E1 cap plus 2 cos I. Cos I value is what? Minus E1 cap n cap into unit vector. Is it clear? So final result you have to remember, E1 cap minus 2 E1 dot n cap, this is the dot product, into the n cap is the unit vector in the direction of the reflecting surface. This is the vector form of the law of reflection. What is the meaning of the vector form? Mean you have given the incident vector, normal vector to the plane surface, and you have to write the unit vector in the direction of the reflecting ray. So E2 is equal to E1 minus 2 n cap into E1 dot n, right, dot n cap, right? Copy this. So now we can do one more two questions, right, based upon this formula, right? A plane reflecting surface, right, is placed in xy plane, in xy plane such that its reflecting surface its reflecting surface is normal to z axis, normal to z axis, right? If a light ray po, vector po is incident, a light is incident at origin o, right? Find unit vector along reflected ray, right? If coordinates of p is, right, a b c. I'm explaining the question, right? I'm explaining the question, then you can better understand. A plane reflecting surface, suppose this is the x-axis, right? This is the y-axis and this is the z-axis, right? This is the z-axis. And the reflecting surface is normal to the z-axis, right? Reflecting surface, reflecting surface is normal to the z-axis, mean this is the reflecting surface over here, right? Like this. This surface is what? Say reflecting surface, and its normal vector is what? The normal vector of this reflecting surface is what? Along the z-axis. Now, if this is the point P, the coordinate of the point P is A, B, C. From this point, the light is incident on the origin along the vector PO, right? After reflection, what will be the, right, unit vector along the reflected ray? So this is the unit vector along the reflected ray you have to find, such that the incident light ray is incident from point P at the origin, right? This is the question, right? Copy this. So how to solve this question? You tell me. If this is the unit vector E1 cap along the direction of the incident ray, this is the incident ray, this is the reflecting ray. So what is the formula you have to apply? E2 is nothing but E1 minus 2 times of E1 cap n cap into n cap. This is the dot product. This is the formula for the unit vector along the direction of the reflected ray. First of all, tell me what is the n cap? N cap is the unit vector perpendicular to the reflecting surface. So this n cap will be equal to what? It is nothing but equal to the k cap. So n cap, very simple, we may write the k cap. And what is the even unit vector you have to write? Listen one thing. If this is the xy plane, right, and this is the origin and this is the point P, and the coordinates are ABC. So what will you write the OP vector? You tell. The OP vector is nothing but AI cap, BJ cap plus CK cap. Is it clear or not? AI plus BJ plus CK cap. But if you want to write the PO vector. So therefore, the PO vector here you are going to write opposite to the OP vector. Right? In this direction, it is minus AI cap, minus BJ cap, minus CK cap. This is the PO vector. So this is the incident ray. So how to find the unit vector along the direction of the incident ray? Unit vector is nothing but vector divided by magnitude of the vector. So what is the vector? Minus AI cap, minus BJ cap, minus CK cap. This is the unit vector. And what is the magnitude of the unit magnitude? Say minus A square plus B square plus C square is equal to what? Minus AI cap minus BJ cap minus CK cap divided by root over A square plus B square plus C square. Is it clear or not? So this is the even cap. This is the n cap. So can you find the even dot n cap? Yes. even dot n cap. What is the even vector? The even vector is this, minus ai minus bj minus ck cap root over a square plus b square plus c square dot, this is the dot product, with which, say n cap. What is the n cap? Say k cap. So what is this dot product? You will get I dot k, j dot k is equal to 0. Only the dot product will be with k dot k 1 minus c upon root over a square plus b square plus c square. So this is the value of the even dot n cap. Fine. So listen one more thing. Now we can put here, therefore the unit vector in the direction of the reflecting ray, this is the E2, unit is E1. What is the even cap? Even cap is minus AI minus BJ minus CK cap divided by root over A square plus B square plus C square minus 2, right, the dot product even dot n cap, and this is minus c upon root over a square plus b square plus c square, right. This is the scalar product or the dot product, you can say. Fine. Into n cap, right. And what is the n cap? The n cap is nothing but the k cap. So if you take the LCM, what is the LCM? Root over a square plus b square plus c square minus ai minus bj minus ck minus minus plus 2c, and this is the k cap. Is it clear or not, you tell? So minus ai minus bj plus ck cap divided by root over a square plus b square plus c square. So this is the unit vector along the direction of the reflection. And what was the even cap? The even cap is nothing but minus ai minus bj minus ck cap upon root over a square plus b square plus c square. So even cap you can write by yourself, right, dividing the vector to by the magnitudes, right, and this is the E2 cap, the unit vector along the reflecting ray. With the help of this formula we can find, right. This type of the question is asked in JEE Advanced, right. Copy this, then I will give you few more. So the shortcut also we can do apply for this type of the question. Listen one thing, how to apply the shortcut. Listen, if you are able to find the incident vector, this is the incident vector, and what is the vector, what is the direction of the normal to the incident plane, say k cap. So the shortcut you may write, this is the incident vector minus I minus B minus ck cap. Only the sign of the unit vector along the direction of the normal is changed. So directly you can write, right, I am writing the statement shortcut, right, shortcut. What is the shortcut? The thing is that the unit vector along the direction of normal is changed. Unit vector along the direction of normal is, right, is reversed, right. Other remains same, are you getting or not? For example, if even vector is what? Even is minus ai minus bj minus ck cap upon a root over a square plus b square plus c square. This is the unit vector. Unit vector mean its magnitude is 1. If it is reflecting surface is xy plane, if reflecting surface, right, if reflecting surface is xy plane, so what is the normal vector? You tell. Normal is k cap. So you have to, therefore, right, therefore if you want to write the reflected unit vector, So only the sign of the right k cap is reverse, and you can directly write a minus bj plus ck cap root over a square plus b square plus c square. But the condition is that you must have the incident unit vector. You understand or not? Listen one thing. If this is the unit vector, suppose you have the unit vector, and if it is right, if it is reflecting it, if it is incident on yz plane, right? So what is the normal vector? You tell. Normal vector, normal is along, say, I cap. Are you getting or not? So what will be the reflecting vector you will write? Only to write the reflecting vector, only the I component which is along the normal, because if it is now in yz plane, so ai cap minus bj cap minus ck cap upon root over a square plus b square plus c square. Is it clear or not, you tell? Fine. So I am explaining you, I am giving you one more example. For example, listen, the question is, for example, if even vector is what, right? It may be written as the 2i plus 3j minus 4k cap, right? And unit vector mean root 2 square plus 3 square plus 4 square, which is root 29. So this is the incident unit vector, right? I am writing in short. And reflecting surface is what? Suppose the xz plane. Are you getting? Reflecting surface is xz plane. So what is the normal? And find unit E2 vector, the unit vector along the reflecting ray. So no need to apply this formula, although you may apply the formula to even dot n cap into n cap. Is it clear or not? Or directly you can write the answer. When you will put all the values in this formula and calculate that, it takes time, and you will get the same answer. If this is the xz plane, so what is the normal? The normal vector is what? Say k, j cap. So only the thing is that what you have to do, the normal vector is nothing but j cap. For this vector, you must reverse the sign of the right 2i minus 3j cap minus 4k cap upon root 29. Is it clear or not, you try? Fine. So this is the shortcut. If you put in this formula, then you will get the same answer. You can try. Right. Listen one more thing. Now, if this is the first reflecting ray, right? Now this reflected ray, now incident on xy plane. Is it clear? Find finally reflected ray. Finally reflected ray, unit vector E2, right? So what will you do? If it is reflecting on, if it is incident on xy plane, so what is the normal vector in this case? If it is in xy plane, normal vector is k cap. So what you have to do? Now you have to change, or you have to reverse the sign of the k cap. You will get the reflecting vector. Therefore, finally E2 vector is nothing but it is 2i minus 3j, right? Just reverse this component and the answer is 29, root upon root 29. So this is the shortcut to solve this type of the question, right? Copy this. One more question we can do in this way, right? If light is emerging if light is emerging, right, from point 2 comma 2 comma 4, right, and incident on incident on xy plane as a mirror, right, at point 1 comma 1 comma 0, right. Find the unit vector along reflected ray along reflected reflected ray if normal to the plane is in plus z direction. All right, copy this. So what is the question? Please try to understand first. Here, suppose this is the x-axis, y-axis, and this is the z-axis, and reflecting plane is simply in z direction. So in xy plane, the mirror is placed over here like this, right? This is the mirror which is placed in xy plane. Are you getting or not like this? This is the mirror. Right, mirror is placed horizontally, you can understand, and this is the normal vector from where, suppose this is the point P, from where the light is originated 2 comma 2 comma 4, it is incident at this point, not at origin. It is incident on this some point over here like this, right, and it is reflected back. So what is the coordinate of this point P where it is reflected? It is in 1 comma 1 comma 0. It means this point is 1 comma 1 comma 0. It is in xy plane. Are you getting or not? This is the unit vector along the normal. So first find the E1 vector, find the N vector, and you have to write the E2 vector. Is it clear or not? So if this is the P and this point is Q, suppose. So how to find the E1 vector? The E1 vector is nothing but the unit vector along the incident ray. So first write the PQ vector. What is the PQ vector? PQ vector is nothing OQ minus OP. I think you must understand from the vector mathematics, right? Right, like this, AB vector is nothing but OB minus OA, right? This is the vector mathematics. What is the OQ? OQ is nothing but the, right, you may write in this way, 1 comma 1 comma 0 minus OP vector is the position vector of point P. OQ vector is the position vector of point Q, right? It is nothing but, it may be written as I plus j plus 0 k cap minus 2i plus 2j plus 4k cap. Are you getting? So I minus 2i is equal to minus I, j minus 2j, say minus j, 0 minus 4k cap. Is it clear or not? So this is the PQ vector, but E1 vector is different. What is the E1 vector? E1 vector is the unit vector. Unit vector is found by giving the but dividing the vector, dividing its magnitude. So minus I minus j minus 4k cap divided by root 1 square plus, right, minus 1 square plus minus 1 square plus minus 4 square, 4 चौक 16, 16 और 2 18, minus I minus j minus 4k cap, and this is what? This is 18 root 18, right? It is 3 root 2, right? So this is the E1 vector we have found, minus I minus 4k cap minus 3 root 2k cap, right? This is the E1 vector. And what is the n cap? The n cap is nothing but the k cap. So what is the formula for the E2? The formula for the E2 cap is nothing but E1 minus 2 E1 dot n cap into n cap, right? This is the dot product multiplied by the unit vector. Are you getting? So First you have to find E1 dot n cap, right? This is the I minus j minus 4k 3 root 2 it is, dot product with k cap you have to do. So what is the answer? I dot k0, j dot k0, k dot k1, so it is equal to minus 4 upon 3 root 2. The dot product of the two quantity is nothing but always a magnitude, right? So that is why its magnitude is coming. So therefore the E2 vector, E2 cap you may write E1 minus I minus j minus 4k cap upon 3 root 2 minus 2 times of minus 4 upon 3 root 2, and this is the k cap. If you simplify, this is what 3 root 2 is the LCM, minus I minus j minus 4k minus minus plus 8k cap. So the answer you will get minus I minus j plus 4k cap upon 3 root 2. So the reflecting vector, the reflecting vector along the reflected ray, unit vector along the reflected ray is minus I minus j plus 4k cap upon 3 root 2. Is it clear or not, you tell? Although you have done this mathematics calculation, instead of this, if this is the k cap, if you want to find the reflecting vector, unit vector along the reflected ray, just reverse the sign of the k cap. Is it clear or not? So you may directly write the answer also, but I have shown you how does it come, right? So directly you can write, but this shortcut is valid only for the mirror plane if it is placed in xy plane, yz plane and zx plane. If the reflecting surface is different, not like this, so you have to apply this formula to find the reflecting ray, right? Copy this. So read this question, right? Look this question. Suppose this is the xy plane, this is the x-axis, y-axis and z-axis, and there is a point, right, on the x-axis 1, 0, 0, and sphere is a spherical reflecting surface. This is the spherical reflecting surface. Spherical reflecting surface. Reflecting surface. Center at 1, 0, 0. Is it clear or not? A light is coming parallel to the x from the negative x-axis, right? This is the incident ray, right? And it hits the point P. Suppose this is the O, the center O. A light ray incident on a light ray coming parallel to x-axis. A light ray coming parallel to x-axis incident on point P, right? This is the point P and the coordinate are 4, 3, 3. This is the spherical surface on P 4, 3, 3. So when it is incident on this, so it will be reflected. Then find unit vector, right? Find E2 cap, right? That is unit vector along reflected ray, right? Copy this. Listen one thing. If this is the incident ray and it is coming parallel to the x-axis, so can you find the incident unit vector? If it is moving in, if it is traveling in the x direction, it is going to the positive x. It was the I cap. It is opposite to the x, minus x. So it is minus I cap. Is it clear or not? You tell. Minus I cap. Right. So even vector we know. This is the unit vector. And what about the n cap? The n cap is nothing but the normal vector over here, right? Like this. This is the n cap. Getting or not, you tell. After this, it will be reflected. So the E2 cap we have to find. So first you have to write the n cap. To find the n cap, what is that? You must write the OP vector first. Right, I'm writing the solution over here. Write the E1 cap, the reflect unit vector along the incident ray is minus I cap. And if this is the OP vector, the OP vector is what? Wait for 1 minute, You don't write this point as the O. You may write this is the point Q, because O for origin, right? This is better because origin means 0, 0, 0 generally. So this is QP vector, right? So the QP vector is nothing but OP minus OQ vector. The OP is nothing but, right, this is the OP, this is the OQ, right, and this is the R vector. You understand or not? So R1 and R2 are the OP and OQ are nothing but the position vector of point P and Q. This is the position vector of point P. This is 4I, 3J plus 3K cap minus OQ vector, I cap plus 0, J cap plus 0, K cap. Right, 4I plus 3I. So this is equal to 3I. Right, 4I minus I, 3J plus 3K cap. All right. So this is the OQP vector, and therefore what is the n vector? The n cap is nothing but QP vector divided by QP vector. So 3I plus 3J plus 3K cap root over, right, its magnitude, 3 square plus 3 square plus 3 square, right. So 3I plus 3J plus 3K, right. This is 3 root 3. All right. So the n cap is nothing but I cap, 3 will cancel out, J cap plus K cap upon root 3. Now you know the n cap, you know the E1 cap. Therefore the E2 vector is nothing but E1 minus 2 E1 dot n cap. First the dot product multiply by the unit vector. So what is the E1 vector? It is minus I cap 2, right. The E1 vector minus I dot. What is the n cap? The n cap is I plus J. It is better to do E1 dot n cap separately. E1 dot n cap is equal to E1 is minus I dot. The n cap is I cap plus J cap plus K cap upon root 3. So I dot this. So I dot I is 1, dot with J and K is 0. So minus 1 by root 3. So its value is minus 1 by root 3. So the E2 vector is nothing but E1 cap minus I minus 2. E1 dot n cap we have found minus 1 upon root 3. It is the dot product, it must be a number. And the n cap is what? N cap is, this is the unit vector I plus J plus K upon root 3. So if you simplify minus I, minus minus plus 2 upon 3, I plus J plus K cap minus 3I plus 2I plus 2J plus 2K cap upon 3. Fine. So the E2 cap is nothing but, right, it is minus I plus 2J cap, right, plus 2K cap upon 3. Is it clear or not? This is the unit vector along the direction of the reflecting ray. Fine. So this is the way how to solve this type of question. Listen one thing here. If this is the E1, does not mean you have to change the sign or other thing as we done in the previous questions. Right? This is a different question. The shortcut is applied if the reflecting surface is what? Say in XY plane, YZ plane, ZX plane, like that. Right? Copy this.